Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my dear classmate. Let me introduce myself. My name is Cahya Suci Ramadhani. My ID number is 24 and I'm from class 5B. It's good to be here today and I hope everybody is good in this pandemic situation, and my topic today is review of chemistry education journal. Did you know Bowen and Bunch reveals that conceptual understanding in chemistry involves the ability to represent and translate the chemical problem into macroscopic, microscopic, and symbolic representations. Simultaneous presentation of a chemical concept with three levels of representation is an important aspect of the chemical learning process. Okay. The title of my presentation is Visualizing Solubilization by a Realistic Particle Model in Chemistry Education. The authors is Antonella, Vincenzo, and Michele A. Floriano. Year of published in 2019. Okay, the next point is abstract. The journal presents an application for the visualization of the mixing process of two different types of structureless interacting particle is presented. The application allows to demonstrate on a qualitative basis as well as by quantitatively monitoring the time evolution of the fraction of aggregates of different size, that the formation of homogeneous mixture is the result of favorable solute-solvent interactions as well as by temperature. It is suggested that along with the use of suitable macroscopic examples, visualization by the present application are useful in elucidating concepts related to miscibility or solubility. The application is based on a two-dimensional realistic dynamic model where atoms move because of their thermal and interaction potential energies, and their trajectories are determined by solving numerically Newton's laws according to a molecular dynamics or MD sim. The keyword is chemistry education, intermolecular interaction, mixtures, molecular dynamics, particle model, and solubility. The introduction is the journal Visualizing Solubilization by a Realistic Particle Model in Chemistry Education was written by Antonella de Vincenzo and Michele A. Floriano. Throughout my reading of this article, it became clear that it focused on the role of the particle model of matter extensively used to interpret and visualize different kinds of chemistry process and phenomena for education purpose, also pointing out its shortcomings as a potential source of misconceptions. The methods is in this part, authors explain an application are useful in elucidating concepts related to miscibility or solubility. He explained the MD simulation method. In the molecular dynamics method, a fixed number of atoms or molecules move in a given volume and behave as classical objects. Their motion is the consequence of both thermal and interaction potential energies. This Java-based platform provides 2D and 3D classical molecular dynamics engines. In addition to ready-made example, the user can design and customize new models or activities. In this part of the explanation, application it is possible. And then the next part is results and discussion. Authors begin with explain about the present application has been designed to introduce the basic concept of the particle model of matter n. It has been pointed out elsewhere that using a realistic model for describing the motion of atoms and molecules rather than using animations based on more or less arbitrary successions of still pictures carries important advantage from an education viewpoint. With this in mind, as explained above, the applications was designed as a realistic MD simulation in which simple structureless monatomic particles move according to Newton's laws of motion. Concepts relate to solubility and the process determining the formation of homogeneous or heterogeneous mixtures are very important in chemistry. In the case under consideration, EA, the mixing process of particles of different types, in addition to parameters defining the identity of the particles' size and mass, the relevant variables are temperature and attractive strike parameters. As a consequence, the application was designed to focus on the latter. The next is the author explains the results report in figure 4. This demonstrates on a qualitative basis that when no interactions are present, two different substances will mix at any temperatures because there is no reason for particles of one type to favor regions rich of particles of the same types. This idea is a qualitative way of describing the spontaneous process which, from a state consisting of two separate A and B substances, leads to a homogeneous A and B mixtures with a corresponding entropy increases. The result report in figure 5 and 6 demonstrate the effect of introducing preferential interaction energies between all particle pairs on the resulting mixtures. The above discussion is further supported by the result reported in figure 7, where the temperature was raised and the consequent dissolution of the aggregates formed at lower temperatures was obtained. Raising the temperature had the effect of shifting the balance between kinetic and potential energies in favor of the former. In summary, the author's opinion, the application here present offer the opportunity of letting the student observe in an interactive fashion the basic submicroscopic details underlying a mixing process. It is possible to use the application at different school levels, from the simple qualitative observation of the dynamic configurations to gradually more detailed semi-quantitative analysis. Also making use of the time evolution of the fractions of the different aggregate species present in the mixtures. The next is conclusion. In the journal, the conclusions of the author's study are presented. The particle model of matter is a powerful tool for describing the structure and the dynamic properties of matter at the submicroscopic level. With the present application, it is possible to demonstrate in a quite effective way that the study of the dynamic behavior is very often crucial in the understanding of fundamental concepts in chemistry. The next is strengths and weakness. The strengths in the journal review is the first, the application here presented offers the opportunity of letting the student observe in an interactive fashion the basic submicroscopic details underlying a mixing process. The second is this journal provides a solution in visualizing solubilization by a realistic particle model in teaching chemistry. The last is the journal also describes the features of the program used in describe the visualizing solubilization by a realistic particle model. The next part is weakness. The first is dynamic illustrations of the submacroscopic work generated by animations might be indistinguishable from those produced by a realistic simulation. The last is the article does not provide information. The weakness from the application are useful in elucidating concepts related to miscibility or solubility. Thank you for attention. Sorry for my mistake. Wassalamualaikum warahmatullahi wabarakatuh.